It is as expected, as you were saying before. It is application aware stateful filtering, and it supports both IPv4 and IPv6 traffic. Supports routing. It's a very capable box. It supports static routing, reversion, TUE, RGRP, OSPF, BGP. I think they had a BGP in code 9 something. Multicast routing, the HTTP server, the HTTP client, so the HTTP services. You can be both a client and a server. It has very advanced NAT configuration, especially starting with 8.3 code. We're going to speak about that exactly. So you can do pretty much all kinds of NAT, static, dynamic, path, port address translation, and source NAT, destination NAT, twice NAT. So you can choose to either as you take an IP packet, you can choose to NAT either the source IP address, destination IP address, or both of them. That's called double NAT or twice NAT. Advanced VPN support. It supports pretty much all kind of VPNs, SSL VPNs, IPv1 VPNs, IPv2 VPNs, and it also has next generation capabilities through the use of Firepower module, which is the source fire, let's say, solution, which that's why in the data sheets we are seeing the next generation IPS and AVC filtering in there. It was the Firepower capabilities in there. Now you can go ahead and deploy the firewall in two modes, either routed mode or transparent mode. Now the routed firewall is going to be when the interfaces are in different subnets and different VLANs, and the physical interfaces are going to be having layer 3 are going to be layer 3 interfaces with IP addresses. Now there's an exception to this rule, because the ASA 5505, all of its ports are layer 2 ports, and the ASA 5505 is going to make use of SVIs just like a regular switch to define the layer 3 ports. So the exception is only on ASA 5505, that even if you run it, doesn't matter the mode, even if you run it in routed mode, because the physical ports are layer 2 ports, are switch ports, then the only way you can actually define it in routed mode, you need a layer 3 IP addresses in pretty much all VLANs. Then you're going to make use of SVIs just like on the switching platforms when you define a layer 3 IP address on a switch in a specific VLAN. And traffic is going to be routed between interfaces. Like I'm going to do the same thing in my diagram in here. So in my case, I'm going to go in here. I'm going to have the SA3, which is going to have those two physical interfaces, gig 00 and gig 01. I'm going to have IP addresses configured. I'm going to have a .16 address on both physical interfaces, a .16 address, but in different subnets. Gig 01 is going to have an IP address, so gig 01 is going to have an IP address from VLAN 37, and gig 00 from VLAN 47. Not only is different VLANs, but it's different IP subnets. So I'm going to have the last octet to be .16, but from different IP subnets. So I'm going to have in here 136.1.47.16, and in here 136.1.37.16. So I'm going to run the ASA in a routed mode, which means it needs to run routing as well as static dynamic in order to be able to route packets back and forward. The other option is going to be to put it in transparent mode or a switch mode, where the interfaces are going to be in the same subnet but different VLANs as well, but both of them are going to be in the same subnet, and physical interfaces pretty much on all devices now, on all types of firewalls, are going to be layer 2 ports with no IP addresses at all, and traffic is going to be bridged between or switched between the interfaces. Like for example, the use case would be when both this VLAN, so this is going to be VLAN 37 and this is going to be VLAN 47, but both of them are going to be in the same subnet. Like this would be the subnet of 10.10.0/24, for example. let's say 10, 10, 10 in VLAN 47, and likewise VLAN 37 is going to be the same, 10, 10, 10, 0, 24. So on both sides of the ASA, I'm going to have different VLANs in order to be able to bridge the traffic through the ASA, different VLANs, 37 and 47, but the same IP subnet. And the ASA is going to have no IP addresses on the physical interfaces. At that point, gig 01 and gig 02 are going to be just switch interfaces. The ASA is going to need, in this case, an IP address in the same subnet, but not for management purposes. Of course, it's going to be used also for management, but in order to be able to bridge traffic back and forth. So if the ASA in bridge mode, it doesn't have an IP address configured, v4 for IPv4 forwarding, v6 for IPv6 forwarding, is not going to be able to bridge any traffic back and forth. In that sense, for a specific use case, based on how they implemented the transfer firewall feature on the ASA, it's a long discussion. It's pretty much a CCA level discussion. But remember, it is an IP address configured, which is going to be used also for management. And even though it's going to work in most cases with an IP address from another subnet, you ideally, because in some use cases it's not going to work, you have to put an IP address in the same subnet as the connected interfaces of the ASA, connected devices of the ASA. Now, why would you want to put the ASA in transparent mode? For example, if you would have this use case in your network, so this is your ISP router in here, ISP, and this is the customer router. And initially they are connected, doesn't matter if they are directly connected or not, or maybe to a switch. They may be connected to a switch, to a fiber converter, to a media converter, to whatever, doesn't matter. Somehow they are connected physically directly, or to other layer 1 transport, layer 2 transport. Physically they are connected, and both of them share the same subnet. Like the ISP is going to have an address, let's say, of 10.10.10.1, and the customer is going to have an IP address of 10.10.10.2. And this is a switch, let's say. So what if you want to inject between the customer and the ISP a firewall to control traffic back and forth? You'd want to inject a firewall in here. So a firewall belonging to the customer, but you don't want to change the IP addressing scheme, or you cannot do that. You have to put the firewall in layer 2 mode, because you want that the devices connected, the layer 2 devices connected on the two sides of the firewall, you want them to be in the same subnet. So that means the firewall has to be deployed like in layer 2 mode. It's going to behave like a switch, but also like a firewall at the same time. Other use case would be, for example, the following. You would have, this is your internet router, for example, and this is your core router in here. You have a DMZ switch in between, So this is your internet router. This is your core router, and this is just a switch. And in here the switch also have connected let's say the web server and the FTP server. And all of these devices are connected in the same VLAN, in the same subnet. This is going to be, let's say, internet router is going to be .1, core router.2, web server.3, FTP server.4, and all of them are going to be a member of the subnet. Likewise, let's say 10.10.10/24. And you don't want to, you cannot, or it's too complicated to change the IP addressing scheme, but you want to likewise inject a firewall in here in between the internet router and the core router. You don't want to inject a firewall in here. And you would want to define this zone towards the internet router as outside, so it's untrusted. It goes to the internet. This side to the core router as inside, it goes to the LAN. It is more trusted. And this side in here facing your servers is DMZ because it is neither trusted, neither untrusted, because both the LAN and the internet are going to access those servers. So and you want to build some firewall policies between these three zones, between the DMZ, the outside, and the inside. But because you don't want to change the IP addressing scheme, it means you have to deploy the firewall in layer 2 mode. So it's going to bridge the traffic back and forth, it's going to switch it back and forth, and also enforce firewall policies.